Hello, class. This will be the video lecture for section 2.5 survey problems. This will be our last lecture for Unit 2 material. I will be putting out like a short test overview video and then another video where I'll work through the full review, or at least a lot of the full review. But this is the last section of notes for test 2. And so on the 2.5 notes, if you're following along in the handouts, in Blackboard, there's the 2.4 and 2.5 handouts are together. So I'll be continuing with that. When we talk about survey problems, what we're going to be doing in 2.5 is basically applications of what we did in 2.3 and 2.4. So, excuse me, instead of just giving you numbers with no context, word problems, now we're going to put context to the information, and then we're still doing set operations and dealing with Venn diagrams. Excuse me. All right, so the other difference between 2.3 and 2.4 versus 2.5 is in 2.3 and 4, we kind of dealt more with the actual elements themselves in the Venn diagram. In 2.5, we're dealing with the cardinality for the, we're not interested in like who answered which question, like, was it Sam or Sophia or Charlie? We're looking at the number of people in each region. Okay, so and you've practiced that a little bit in 2.4, the cardinality. So that's all of 2.5 is dealing with that. Okay, so let's jump into the notes. And I'm going to do this sort of two parts. There's like 3 examples I want to do from the handout. And these are sort of like just jumping into the problems and doing them. So I want to kind of start there since we're working together with this. And then I'll back up and get into MATLAB. And MATLAB kind of starts small and kind of works the way up. But like I said, since we're here working together, let's just kind of jump into it and see what happens. Okay, so from the like I said, the 2.4 handout that we did last time, we had talked about some of the shading. And one of the things that's going to be important, particularly when we get into 3-set Venn diagrams, is we're going to have to build. Oh, sorry about that. All right. So part of the disadvantage of doing this in my office, I have to get phone calls occasionally. All right. So back to survey problems. All right. So in MATLAB, they're gonna just like with word operations or equations, they kind of start small and work your way up. Like I said, we're gonna kind of jump into the deep end at the moment, kind of work backwards. But in general, what we're going to be doing is we're going to be taking this information, we're going to be creating a Venn diagram. Once we create the Venn diagram with all the numbers in the right spot, then we'll be able to answer questions. And when you're starting with Venn diagram, whether it's 2 or 3-set Venn diagrams, we want to, there's multiple regions that numbers might go. And so what you want to look for is there one specific region that one number can go? If not, if there's like multiple regions, then we need to save that number till later. And so in general, we want to start with the intersections, right? Because the intersection, like, for a 3-set Venn diagram, there's what's in all 3. If it's a 2-set Venn diagram, it's just in the middle. But that's kind of where we're going to start. Is we're going to start with those intersections and kind of work our way out. And one of the most common mistakes, particularly with the 3-set Venn diagram, and we're going to go over this multiple times, is that if you're starting in the middle and working your way out, you need to subtract your numbers because you've already accounted for some of them. So, and you'll see what I mean, particularly when we get to the once we start putting the diagrams. But that is one of the most core mistakes. The 2.5 is not knowing the difference basically between like B being like that whole circle versus B only being that one spot of B. Okay, so let's start with number 16 and see what we're doing here. All right, the results of a survey of 50 students indicate that 30 like jelly beans, 29 like green, and 17 like both red and green. How many students surveyed like no green jelly beans? All right, so to answer this question, we need to make a Venn diagram. First thing on the Venn diagram, are we dealing with a 2-set or 3-set Venn diagram? So we go back to the information, talking about red jelly beans, green jelly beans, and both. So is it 2 or 3 sets? Well, often I hear 3 sets, but for 3 sets, that would mean we need, so we have red, we have green. If we wanted a third set, it'd be like blue jelly beans. Okay, so that both red and green, those are already, in our sets. Okay, so let's create a Venn diagram. Okay. All right. So for red, that's going to be where my A normally is, and we use pink. Let's see. Let's go ahead and use purple for the green. I know it's green, but let's make sure everybody can see it. Okay, so those are our 2 sets. Okay, and so the 30 that like red, well, one thing you need to be able to do, and we talked about this a little bit in 2.4, is put that in set notation. So that 30 who like red, that would be the number of red equals, what's it, 30? And then the number of green is 29, so that'd be number of green, 29. And then 17 like both. So if they like both, what you need to recognize is that's intersection. All right, and then what we have another number, there was 50 students, so don't overlook that. So what is that 50 students? Well, the 50 students is everybody that's surveyed. So that tells us the number in the universe is 50. All right, so how do we put all that information into this Venn diagram? Okay. Well, can we start with the number of red is 30? Well, if you put 30 over here, you've made the core mistake of confusing only red versus the entire set. So red is both those regions. So there's 2 regions that 30 could go into. And since there's 2 regions, we can't use that 30 yet. Same with green. Yeah, so that circle likes green. There's 2 regions for green. So I can't put the 29 yet because I can only have one area. So we'll back up to that. Now we know that the number of people who like both are 17. Well, we can deal with that because 17, the both is the intersection. Okay, so we know that 17 go in the middle. Yep. So what I like to do is I use my numbers. I like to check them off. All right. So the universe, can we use 50? No, because that entire box has to add up to 50. And so I've got like 3 regions that aren't, so I don't know how to break up those 50. So let's go back to the 30. So the number of red, people who like red jelly beans is 30. Again, do not put 30 here because if you put 30 here, you're saying that 30 plus 17 like red jelly beans, but there's only 30. So what you have to do is that if it said red only, then you put the 30 there. We don't have the word only, so what we have to do is subtraction. So we need 30 in the circle. We've already counted for 17, so 13 left over. So there are 30 people total who like red jelly beans. 17 of them happen to like green as well. 13 of them only like green. So now we've used the 30. So what do we do with the 29? Well, that's 29 people like green jelly beans. So if you go back to our Venn diagram, there is green. We need 29 in that circle. We already have 17. So you do 29 minus 17, you get 12. The number one mistake with survey problems is not doing that subtraction. Okay, the only reason you wouldn't do the subtraction if there was the word only in there with the numbers. Okay. And so if you're missing that, you're missing like the core concept of 2.5. All right, so are we done with the Venn diagram? No, because we don't have the number outside. And so how do we get that number outside? Well, this is where that 50 students were surveyed. How many have we accounted for? Well, 13, 17, it's 12. This is where you do your arithmetic in this. So the unit is all your age tracking. So those together add up to 42. And so then 50 minus 42 gives us 8. So there are 8 people not accounted for. All right. If you are creating your Venn diagrams and you get negative numbers, once you start getting outwards, well, if you get negative numbers, it's because you didn't subtract when you're doing regions like this. All right, so that's the first step, is complete the Venn diagram. We're going to put how many elements are in each region of our Venn diagram. So now what's the question? So the question is, how many students liked no green jelly beans? So we don't want green jelly beans. So that means we're doing green not, right? The complement. So how do you do that? Well, we don't want green. So cover up that circle. So how many people are left? 13 plus 8. So 21 people liked no green jelly beans. 13 of them happen to like red, 8 of them happen to like neither color, but total of 21 people um, did not like green jelly beans. All right, so this is a pretty typical problem. So this one's kind of straightforward because we give you, the entire set of red, we give you the entire set of green, we give you the intersection. So that one's, like I said, that is a straightforward, typical problem. Now we can get a little messier. So let's test your knowledge here. Yeah. So next one, Monticello residents have surveyed concerning their preferences for candidates Moore or Allen in the upcoming election. Of the 800 respondents, 300 support neither Moore nor Allen, 100 support both Moore and Allen, and 250 support only Moore. How many residents support Moore or Allen? Okay. So first thing, create a Venn diagram. So how many sets are we dealing with? Well, the number of sets is the number of candidates in this case. So the two sets are Moore and some color. Orange is going to be Allen. Regular is going to be. Okay, so let's write out our numbers. So we have 800, so 800 respondents. So that 800 is the total. So that would be the number of our universe. And so the entire box has to add up to 800. 300 support neither. Now, if you're not for sure, like what the notation is, then just write out the number and we'll deal with it later. 100 support both. Now, if they support both, that would be more intersection Allen. So we know the number of the intersection is 100. Okay, and then 250 support only one. And then the question is how many support Moore or Allen. All right, so let's go through here and see which numbers can be placed. So we know there's 800 respondents. We can't use 800 yet because that entire box has to add up to 800. So there's 4 places, to split up to 800. We can't use that yet. Okay, so how about the 300 support neither? Can we use that? Where is they support neither? Okay, well, if they don't support either of them, that means they're not in the Moore circle. They're not in the Allen circle. That means they're outside the circle. Okay. And we typically put in the bottom, it can go on the top, it can go on the side, doesn't matter as long as it's outside the circle. Okay, so we've taken care of the 300. So now 100 support both. Yeah, so where's, if they support both, that's the intersection. So that's the middle. Okay. And so now the next number is 250 support only Moore. The key word on this is only. So what does that only mean? Well, that only means it's in just, and this is like region 1, So it's just this part of the more circle, not the whole circle. Because that 250, none of those can be in here because those people support Allen as well. So that only means we actually don't subtract. We just put that number right there. Okay. So now we have one region without a number. How do we get that? Well, almost pretty much always when you're doing these survey problems, that last region, you always go back to the universe, like the number of people surveyed or number of respondents or whatever. So we know we have 800 total. How much have we accounted for? Well, we've accounted for 250, 100, and 300. So we've counted for 750 people total. And so we know there was 800 surveyed, counted for 750, so there's 50 left. So that 50 goes there. All right, so now we've completed all regions of the Venn diagram. Now let's answer the questions. So how many residents supported more or Allen? So the key there is or. Right? So remember, or is union. So we're basically doing more union Allen. And what's the definition of union? It is all the elements in the first set as well as all the elements in the second set. So that means that is everybody that prefers more or everybody that prefers Allen. So the union is everything in those sets. So the union is the or is 250 plus 100 plus 50. That's 300, 400. Okay. No, 300, 400. All right. I feel like I've made a mistake somewhere. And the reason I'm questioning this is if there's 400 people that like Moore or Allen, 300 people who don't, that's a total of 700 people. I'm supposed to have 800, right? So I've made a arithmetic mistake somewhere. Let's see. Oh, I can't add. All right. I'm sure if we were in the classroom, somebody would have pointed it out. I'm sorry. See, this is what happens when you do math when you're hungry. So that's supposed to be 650. That's 150. All right. But again, this is where like, you know, that's I knew I made a mistake, and so instead of panicking, I just tried to figure out, back up and see what happened. And so it's easy to make arithmetic mistakes and stuff like this. So if you get in there in math lab and you get a wrong answer, then just slow down, see if you made a basic mistake or something else is going on. Yeah. But now, so 500 people supported either candidate, 300 didn't. Now, here's another thing. Did we have to do all of this? Well, it depends on how comfortable you are with the content. So how many residents support Moore or Allen? So if I knew that I'm looking for inside the circles and I was given the fact that 300 support neither, well, then I could have right off the bat just did 800 minus 300. Because 300 support neither, that means everybody else supports one or the other or both. So I could have got that a little bit quicker, but that's only if you're more comfortable with the content. Okay, so this is sort of a messy one because normally, like I said, we give you the intersection and then we give you these where you have to subtract as you move outwards, and then like this is the last thing you figure. But it just sort of depends on the given information. Again, watch out for that word only. You have that word only, it goes in that one region and you don't have to worry about doing the subtract. Okay, so my arithmetic mistake didn't throw you off there. Let's get into a three-set Venn diagram. Okay. So the survey of 142 college students was done to find out what elective courses they were taking. So A is those taking art, B is taking basket weaving, and C is canoeing. Yes, those are all completely made up classes, but I wanted my A, B, and C to be consistent. All right. So the study revealed the following information. Okay, so we have number of A in art is 45, number in B is 55, number in C is 40, number of A intersection B intersection C is 2, and then intersection of A and B is 12, 15 for A and C, and then B and C is 23. So how many students were not taking any of these electives? So when you're in math lab, um, and these are more towards the end, the second half of the 2.5 homework, sometimes they'll ask one question, sometimes they'll ask multiple questions. But before you can answer those questions, you need a Venn diagram. We definitely have a three-step Venn diagram, because we do have now A, B, and C. So there's our art circle, there's our basket weaving circle, and here is our chameleon circle. Then our universe is everybody that responded. Okay, so where do you start? Okay, so can we deal with the number of A is 45? Well, if you look at that, where is A in this Venn diagram? A is those three regions. It's that entire circle. So there's 3 places or 4 places, sorry, that 45 has to go. We don't know how to split it up, so we can't use the 45 yet. Same with the 55. Let's say 55 people are in that circle somewhere in those 4 spots. Same with the 40. So 40 people are somewhere in that circle. Can we use A intersection B is 12? Well, A intersection B, now here's where you have, notice that doesn't say anything about C. So you kind of have to ignore the C circle. So if we want A intersection B, that's the overlap. So that's the 2 regions there. So those intersections of A and B, A and C, B and C, we can't use those yet because there's 2 places that the numbers go. That's why I say when you're putting these numbers in the Venn diagram, always start in the very middle. We have the intersection of all 3. So that's in the very middle. There's going to be 2 people. Okay. All right. Sorry, that looks like a 1. Okay. So now we start working our way out. So now we're going to go back to these intersections. So for A and B, we know there's 12. We've already accounted for 2. So we need to do 12 minus 2 is 10. So that means 10 people. I didn't make my Venn diagram big enough, sorry. So there are 12 people total in A and B. 10 of them weren't in C, 2 of them were, but a total of 12. So this is why I say as you go outwards, you have to be subtracting. If you're not subtracting, then you're going to run out of people and you're going to get negative numbers in the end, almost always. Okay, so for A intersection C, well, A intersection C is those 2 regions. So there's 15 there. So we've accounted for 2 of them. So 15 minus 2 gives us 13. So there are 13 people who like A or in A and C, but not B, but a total of 15 in A or C. And then I think you're kind of getting the hint here. So for 23 that like B or C, so there's 23 there. We've already accounted for 2. So 23 minus 2 will be 21. All right. And so now we just kind of keep working outwards. And so now if you go back to the number of A, so there's 45. Well, there's 45 in this entire circle. We've accounted for 10 and 2 and 13. So that is 25. So we've accounted for 25 already. There's supposed to be 45 in there. So 45 minus 25 is 20. So 20 goes there. So that circle adds up to 45. What does B circle add up to? Well, B has to add up to 55. So what have we done for B? Well, we have 10 and 2 and 21 already accounted for. So there's 33 there already. There's supposed to be 55. Just 22 not accounted for. So 22 go there. Okay, and then for C, there's a total of 40 in this circle. I mean, we accounted for 13 and 2, 21. 6, there's 36. There are 40 total in C. So 40 minus 36 gives us 4. All right. So are we done with the Venn diagram? Almost. We need the number outside. So how do we get that number outside? This is where we go back to the total. So that total tells us that there has to be 142 total in the entire Venn diagram. And how many have we accounted for? We need 142. And so now we just basically add these up. All right. Now I'd cheat a little bit, excuse me, because I know A adds up to 45. So those 4 are going to add up to 45. And then I've got 22, 21, and 4. Okay, or you can, add them all up separately, but all right. Considering my arithmetic on the last one, I'm going to grab a calculator. So it'll be 92 that have taken an elective of some sort. We need 142 total. Subtract that 92, leaves us with 50. They have not taken any elective. Okay. So that is, and like this is like maybe I think the last 3 problems in the homework in this section. You're going to have to do this every time. Is you're going to have to take that information and create a Venn diagram for it. So when you're doing your test, this is what I want to see for this problem, because if you don't put this Venn diagram on here and you just give me numbers, I'm going to have, and you get them wrong, I'm going to have no idea where your numbers came from. But if you give me your numbers, if the numbers are wrong, then I can still give you credit if you're answering, right from your numbers. That's that error carried forward. Okay, so what are we actually asking here? So how many students are not taking any of these electives? So if they're not taking any, that means none of those circles, right? So cover all those up. No, they're not taking art, they're not taking basket weaving, they're not taking canoeing. What are we left with? 50. So for this particular question, once we get the outside, we're done. But now what I'm going to do is ask you multiple questions from the Venn diagram that we've already created. That way you don't have to create a whole new Venn diagram. Okay. All right, so some other questions could be, so how many people are taking one elective? Okay, so how do you answer that from the Venn diagram? Well, where on here is somebody that's only taking one? This is the onlys, right? So it's the 20, the 22, and the 4. And so what is that? 42, 46. And again, I want to see this on your test because that tells me where you're getting your numbers from. This is showing your work. These problems get missed a lot because of the Venn diagram issues. And so if you want partial credit on this problem on the test, you need to show me this stuff. All right, how about I say how many people, I'm just gonna, that's gonna be in every question, are taking at least one. Here, the new thing is at least one. So that means they could be taking one elective, they could be taking 2 electives, or they could be taking 3. So where is that on the Venn diagram? Well, one elective would be in the only region. If they're taking 2, that would be the 13 and the 10 and the 21 region. If you're taking 3, that would be in the middle. So if we're saying how many are taking at least one, that's actually the union of the whole thing. And so that would be, 20 plus 10 plus 22 plus 13 plus 2 plus 21 plus 4. Now, I will say that we've actually already figured this out because to get that 50, we had to add up all those numbers. And so from previous problem, that was 92. All right, so how about some other questions? So how many people are taking 2 electives? So where at on the Venn diagram is taking 2? Well, if it's, no, that means they're not taking 3, they're taking 2. That would be the 13, the 10, and the 21. That'd be 23, so 40. Excuse me. So these are the kind of questions that we can ask. How many are taking? Let's see, basket weaving. Or, oh, sorry. All right, sorry. Never had this many phone calls, videos before. All right, so back to the question. How many people are taking basket weaving or art? So how would we answer that? All right, so basket weaving or art. So that or is important because that's or means union. So we're basically doing the union of A and B. So the union, so we're basically ignoring C. The union would be everybody in B as well as everybody in A. Okay. And we are counting 13, the 2, and 21. We don't care that they're taking canoeing because the question says nothing about canoeing. So we would add up everything in A, everything in B. So it'd be 20 plus 10 plus 2 plus 13. That's everything in A. And then we don't count the 10 and 2 again because they're already counted. Then 22 and 21. So when you're doing ors, that's everything, and again, don't count it twice. And then we just add all those up. So what's it? 30 plus 15. Okay. So this is where it can be a bit challenging, is even though we're dealing with 3 sets, we could easily ask you questions that are just talking about 2 sets, and you have to basically ignore the 3rd set. So like if I was talking about B or C, then you have to ignore A and just think of that as 2 circles. Right. So, all right. But this is sort of like this is the sort of the top end problems in 2.5. Is we're going to give you information like this for a 3-set Venn diagram. You have to create your 3-set Venn diagram with numbers in all the regions. And then we're going to ask you, on the test, I'll try to make sure to ask you at least multiple questions. That way, you use that information more than once. But MATLAB may just ask one question and then do another Venn diagram. All right, so let's get into virtual MATLAB. Share that screen. Oh, and I was logged out too long. It doesn't like that. Okay, so now let's go into the 2.5 work. And again, notice this is the last unit of new notes before the test. And so that's why next week is test week. All right, so let's just jump into some problems and see what they look like. All right, so, as always, you start with some definition. So in survey problems, the word blank means intersection. Well, hopefully by now you're used to intersection. Now we used to think of it as and. The but, I'm trying to think of an example off the top of my head. I don't normally use that. So just the and is what we're looking for. Yeah. There. And so union, well, union is definitely or. And then what does the not mean? Not is our complement. Okay. So definitions each started. So let's see how they start this. So here's my number 4. The Venn diagram on the right shows the results of GFK Roper Public Affairs, whatever that is, and Media Survey of 1967 American adult, of 1,967 American adults. That's not the year, taken on October 9th, 2012. All right, so they surveyed almost 2,000 adults, and then they have this Venn diagram over here. How do people feel about pets? And this is true or false. 62 surveyed liked cats. Okay, so is that true or is that false? Okay, so let's go over here. And so if you're saying false because you're saying 6% like cats, you have to be very careful because that 6% only likes cats. So remember, when you're dealing with these Venn diagrams, the circle is the set. So there's 6 and 56. 56 happen to like dogs as well, but we don't care about dogs because we're just talking about cats. So 56 plus 6 is 62. So that is true. So 60, it's not false because they gave us the right number. Okay. 28. So same setup. 28% of those surveyed like dogs, but not cats. So that means they're in the dog circle, but not in the cat circle. So that means that 28%, another way to say this, 28% only like dogs. So again, that would be true because they're in the dog circle, but not in the cat circle. Okay. 7% liked neither cats nor dogs. Okay. Well, the neither is outside, so that's definitely true. All right, all these true. At least has one be false. So 60% like cats or dogs. So is that true? Well, this is where the or versus and is important. So if that was and, it would be true. Because 60% is in the middle, so that 60% likes cats and dogs. But remember, the or is the union, so you have to add them all up. So that'd be 64 plus 29, so that'd be what, 93%. And so the statement is false because 93% like cats or dogs. All right, so again, that kind of goes back, you know your regions, and now we're just putting a kind of a context to it. All right, so here's another typical example. This is question 10. So we're given a Venn diagram. Now, the numbers here, remember, these are not elements, these are the number of elements. So there are 17 elements in region 1, 6 in region 2, and so on. And so I kind of wish they would highlight the question a little bit better. But we're trying to determine the number of elements that belong to B, but not A. So we want them B. We want them in the B circle, but not A. So we can't take that 6 there. So that leaves us with 16. How about this one? Use the Venn diagram, shows the number of elements in the region 2. So they give us the overlap, and then they want to find the number of elements in each of the regions. Okay. So this basically means we have to fill out the Venn diagram. Let me jump over. All right, so what do we know? You already know 12. Okay, and so region 1, region 2. And they're always going to give you these regions. So if they're asking about the regions, those will always be on the Venn diagram. So you don't have to like, remember which one's which. And what else do they tell us? Number of A is 28. Number of B is 29. And then the number of universe is 52. So how do we deal with these numbers? All right. So what do we do with that 28? So I'm hoping by now you're not just plugging the 28 in there, because that if you did, you're saying there's only the 28 people only like A. Remember, A is the entire circle. Okay. So we've already accounted for 12. So that leaves us 16 people not accounted for in A. 16 goes in only A. And then the same with B. And B is the entire circle, already accounted for 12. That leaves us 17. So that 17 goes in only B, but a total of 29. So then what do we do with the number in the universe? Well, we haven't got the number out here. So how many people have we accounted for? 16 plus 12 plus 17 is 45. So there's 45 already. So what we do is subtract those 45 from the 52. That leaves us with 7. So that 7 goes on the outside. All right. And so now what they're doing here is, so once you do that, and again, if you got negative numbers by the time you get here, that's because you were not subtracting. And so like if you just put 28 there and 29 there, you're going to get way more than 52 when you add them all up. So this one is, region 1 has how many elements? Well, region 1 has 16. And then it'll ask you like each region. So region 2 has 12, region 3 has 17, region 4 has 7. All right, so there's really no context there, but we're in that theme of problems. All right, so let's go back to my math plan. All right, so now we have, similar to the last problem we did, concrete Venn diagram. So we're given, the universe, we're given A, B, C, and the intersections of 2. Now, they didn't give you the intersection of A, B, and C over here, but they did put it in the Venn diagram itself. All right, so let's work through this one. This may be the last example I think we could do here. So we know there's 6 in the middle. Okay. Let me go back to the screen. Okay, so this is what we know so far. All right, and so now we're going to start going outwards. So we need these 3 regions. So this region is A intersect B, and they tell us that number of A intersect B is 14. So this region has to have 14. So we've already accounted for 6. That leaves 8 to go there. Now, what is this region? Well, that's a part of A intersection C. So A intersection C is both of those. So what do we know about A intersection C? That is 8. Okay. So there are 8 people in these 2 regions. We've already accounted for 6. That means there are 2 left over that go there. Right. And then for here, that's the intersection. These 2 are the intersection of A, B, and C. And that is 13. So 13 people are in those two regions. We've already accounted for 6. So there are 7 in that region. All right. So again, you got to subtract as you move outwards. You know, to take into account the ones that you've already have there. So now we can do the A, B, and C only regions. And so what do we know about A? Number of A is 20. Number of A is 20. And so we know in A, it's those 4 regions, that's the entire circle. We've already counted for, see, 8 and 2 is 10. We've already counted for 16. We're going to subtract 16 from the 20. Let me just get the color on this. There's 4 left, and so that means there are 4 people only in A, but 20 in A altogether. So what do you know about B? B has 30. So in B, we've accounted for, let's see, 8 and 6 is 14. 14 and 1, 7 is 21. Subtract 21, we have 9. So 9 are only in B, and then a third 30 total. So hopefully you're kind of getting the flow, right? So now we go to C. C is 20. So in C, we've already accounted for 8 and 7 is 15. That's going to give us 5 left over. So there's 5 only in C, and then 20 total in C. And then typically the last number we get is the outside. We know the number in the universe is 44. And so how many have we accounted for? Like I said, I'm going to cheat a little bit. I know A is 20. So there's 20 plus 9 plus 7 plus 5. So what does that give us? So that's 41. So then to get the number on the outside, not any of them, 41, 44 minus 41 gives us 3. All right. And so that's the main work on a problem like this is filling out that Venn diagram. Okay? And again, I can't emphasize enough the importance of as you go outwards, you always start in the center and work outwards and then subtract as you move out. Because if you just try to put like a 14 there, that isn't that, that's in A and B, but not C. This does not say not C. It just says A intersection B. So you got to know that the intersection of 2 sets are both, 2 regions. And so on. And then in the question they ask for, they just start asking for the elements in each region. And so, you have, 1, 2, 3, 4, 5, 6. They got the regions labeled. So then you can just pick the numbers. All right, and then you'll have one that you have to do this, but instead of listing the numbers in each regions, then they'll ask the questions like I was asking before, of like only taking one or or taking at least one, that sort of thing. All right, so at this point, I could do more examples, but I think you really just need to get in there and work on it yourself. And then when you have questions, we can go from there. As always, if you have questions, please email me. There's that Ask My Instructor button in all the homework. Very few people are using that these days. A lot of people are using it at the beginning semester and they kind of tailed off. So I don't know if that means that you don't need it or what, but if you have questions, email me. All right, that's all I have. I will catch you later.